Hi guys, and welcome to another Houdini tutorial. Yesterday I posted a procedural texture we created for our water in one of our games, and I got some uh, questions on how I did it. Could I create a tutorial? So I've decided to do a tutorial. I'm not going to do a tutorial on the water, but I'm going to do a tutorial on something else because I like creativity, but it's the same approach how to create pretty much anything, any procedural texture in Houdini, and how you can bake it out, um, and it can be even seamless if you want to. So let's start. I'm going to start with two geonodes. First one will be our high-res geonode. It will be basically our high-res geometry that will be later to baked to the low-res geometry in the second node. Both of the nodes will start with a grid. The low-res node will also need a texture, UV texture, because we are going to basically map the high-res uh, to that model. I just want to check if the texture is okay. Okay, it's mapped correctly. Now we are going to create a geonode in the grid node in our high-res model, and I obviously want the higher res than this. I would prefer not to use a grid-based subdivision, so I work with the 10 by 10 grid and then use a remesh node that will change the topology, which is way better if you want to do a displacement on it. And then additionally I will subdivide it even further using a bit more subdivisions. And obviously, since we are going to do a displacement, we will need normals. So let's add a normal node as well. Okay, I'm going to disable the low res just so we don't get this overlapping. And the main magic will be done in the point WOP node. So let's add it and dive right in. We will work with displacement, so let's add the displace along normal. That's why we needed the normals as well, and plug it in with the position and the normal, and plug out the displaced position. And now let's start with the noise. Uh, there are some noise nodes here. What we are going to use is the unified noise. You have two unified noise nodes. The static noise node is faster because it's precompiled. It lacks some features of the unified noise, like dynamic parameters, but we will use it for our use case. We also need the position uh, to know the position inside the generated noise. So let's start. We can plug the noise into color just to see it. No, not normal color. So we'll see our noise right away. We can also plug it to the amount of displacement, so we'll get the displacement as well. This is not really the noise we want. I'm going to work with Worley Cellular. This is the best noise for rocks, or what I want to achieve, which is some kind of lava rock. We will also use a periodic flag because we want that texture to be seamless, to repeat itself. As we can see right now, it repeats even within the texture, which we doesn't really want. We want it to be repeated outside of the texture, so we can tile it. Let's dial down the frequency as well, and to get the repeatable amount we need in the period is basically multiply this number by the size of of the object we are applying the noise into. So our grid is 10 by 10, which is the default grid in Houdini. So 10 times half is 5. So now we will get this repeatable repeatable pattern. As you can see, it repeats when it ends here. It's here. It's quite visible that it repeats outside of the texture, but not inside it. Let me turn down the specular so it doesn't creep on us. Okay, what we need to do additionally is create a fit node to fit our range for displacement. What fit node does is basically it clamps the source or remaps the source min-max to this destination min-max. So my source maximum wants to be less than 1 because I want this to have a flat top. So let's just dial it here, as you can see. But the distance, the amount will still be the same because it's remapped to 0, 1. So this range is remapped to this range. If I decrease this destination as well, you will see that it's getting flatter. So this is something a bit what I want. Even maybe less, but I don't really need this to be as deep. So let's dial it up as well. So we do flatten it a bit. Okay, so this is okay for our displacement. I will additionally create, because you can inside the unified noise, fractal noise that will put a noise on top of the noise basically. So let me show you. This will noise a bit, so it's not as just Voronoi. You will have some additional distortion. So let's play with this. We don't really need that much of it. So just dial it down somewhere. Okay, we just somewhere like okay, this even less, something like this, maybe even a bit more. Okay, so we get some additional noise, but it's not really that much. And we want to remove this color and create a ramp because we want to map the color to the color gradient we want. You can change it here, but it will not affect the output. So I don't know why Houdini allows you to change it here. You can even change the color and nothing will happen, obviously, because since it's a parameter, you need to change it outside of the point WOP. That's what we actually want, but so just so we are not confused. So let's dial it a bit. We want the lava here, so lava is really yellow at the bottom, or yellowish. Then there is the red part, and then there is the stone itself. Let's add some color, a bit of color at least. Let me turn down the wireframe. Okay, you can play with it. This is how it's distributed over the range. So now we are getting some nice output of the lava between the stones. So for a fairly simple game, this is even a nice texture. So I will jump into how you bake it out, and then I will come back to this node and make it make it a bit more interesting. So let's start with the baking. We will need a material for both our objects. So they support the both attributes basically. So let's just create the simple principled shader. They drag it to one object and to another object, to the lowest object as well. What do you need to change? Because by default, I don't know, for some reason the principled shader has a base color of gray. So if you don't really want this to affect your texture, you just need to put it to white. So it's not multiplied by this gray color. And now we will need a ROP network and a bake texture node. So we will pick a low-res object and a high-res object. So we are basically baking this one to this one. Let's check it out if it does anything. Oh, let's first change some stuff. What I do? Okay, I'm working with UDIM and I want an XR format, and I want to bake displacement, and I also want to bake the base color. So let's render to and play and see what we will get out of it. Okay. Okay, so it is empty. The main issue why it's black probably is you don't really have a good ray bias, because how baking works in any pretty much any software is that it takes the target surface and then moves the camera by a ray offset, which is this offset, and then tries to render it. But this is pretty small offset for us because this object is one away from this object. So we really need to increase the ray bias. And let's try it out. Okay, just a bit of asset issue. Okay, now we see some output. We are getting the color, the displacement as well, but it's still not enough. So we need to increase this bias a bit more. You can play with it. So the bias should basically be the highest number should be the highest offset. Not that complex. So now we are probably going to get all the information we need. So we get the displacement as well as base color, and we can use this in our game if we want to. If for some reason you wanted the normals as well, let's try it out because it's pretty standard in game development. You are not going to get them, and I will tell you why. So let's just switch to normal. You are getting this normally. It looks like there is no normals. There actually are normals because we created them using the normal, but let me show them. Okay, I'm going to dial this subdivision just to speed it up a bit. Let me show you the normals. Even here, all normals obviously are pointing upwards because it is a flat grid. It should be pointing upwards. But here, after the point warp, we really want these normals to be pointing sideways, but they are all pointing upwards. Why? Well, because basically we didn't recalculate the normals after the displacement. The displacement has this output, which is really tempting to just plug it here, but as you can see, the normals are still pointing upwards. It didn't change anything. So let me change it. Because this works only in a shader context, because there are shader derivatives needed, and it's not really available in the point context. So what we need to do is on the point WOP, with the attribute bindings, we need to update normals if displaced. And this, as you can see, changed our normals. So we can just turn it off. Obviously, it affects lighting as well, as you can see. So now I'm just going to dial this up. Now, when I bake the normals as well, let's wait. Now, when I bake the normals, I have them correctly here. I can take it to the game. There are other channels that you can bake as well. For example, the occlusion. It takes a bit of time, but you can bake pretty much everything there. So if you want to bake to disk, you just set the output, and then there is these suffixes for all the channels that will be baked separately. I'm not going to do that. It's pretty much self-explanatory. What can happen to you, and it's kind of misleading, is that if you don't really have this object active, because I worked like this, I don't really need to see the low-res object. If you try to bake it now, it will throw an error on you. The error saying that there is no match for that object. Why there is no match when we have that object? Because it needs to have it active. To change this setting, you go to Advanced. As you can see, it takes these objects, and you drag the low-res object to force objects. So it's always forced. Don't really needs to be active. So now when I can render it, and it will work. Obviously, as usual. So as I said, this is how you bake the textures. Let's go back to the high-res and make this texture a bit more interesting. You can stop right now if you want to, and if you want to continue, feel free. I'm just going to add some more noise into this so it just looks a bit better. So we are going to create additional noise inside the point WOP. Again, drag the position here, and we want something more frequent. So because it's a detail. Obviously, we also want it to repeat itself. As I said, if you want to repeat over 10 by 10, you need to multiply. So the period will be 15, 15. And we just want to add the standard fractals. Well, you can play with these numbers and to see what you really want to achieve. And we want this to add to the displacement as well as color. So let's go. To add it to displacement, we will need to use an add node, and we are going to add this to. It doesn't really matter uh, which is first and which is second. It's commutative anyway. So, and let's add it to this amount. And as you can see, we got some additional noise, but this is a bit too much. So let's add a fit range again to just clamp it to get nice output. And we just want to clamp the destination to map it to just really small range. So let's something like this. And as you can see, it's not flat anymore. You got some nice small noise. Just because the rocks are never flat, so just get some nice noise on top of it. Now let's add the color as well. We're going to use an additional ramp parameter. And then we are going to multiply, not add, because it's not really a good idea to add two colors and never. So let's multiply, and we want to multiply the base color, which is the we already have, by this one, because it's a detail. So let's plug this in, but it will be a mess. So what we see here is a bit too much difference between the colors. So we want to, and we are using actually this ramp for the detail color as well, because we didn't specify the name. So this, even though it's ramp 2 here and ramp 1, it's pointing to the same attribute or same property name of the point VOP. So we want to have this. Okay, let's call it detail. The detail. Now let's go out, and we have this second ramp called detail, and we really want this to have a minimal difference, just a bit of detail, additional detail to add. And we didn't change the noise probably because we want, okay, we want to use the Worley as well. So this is what I was trying to achieve. So let's go back to the ramp. And I really want just a bit of difference, something like this maybe. Okay, I just got over. So we added this detail to our stone. So it has additional noise and additional color as well. So if we bake the texture now, you will see the additional noise on the normals as well. So the normals on the top of the stones will no longer be flat like they were in the previous bake. And as you can see, you have this additional detail there. But we can go even further to get, if you work with a Substance Designer, for example, you get this nice like different color on the edges based on the curvature of the primitive or of the object. We can do this inside Houdini as well. So I'm going to try it out. We need a measure node to measure the curvature. We want the curvature, and you can do curveness principle. It doesn't matter. You can check the documentation on this measure node what these different. Sorry, my mic just dropped off. So for what these different approaches to measuring curvature mean, I'm going to use principle, and we get the curvature attribute, and we are going to use it to set a color for the object. So now we just don't want the byte color, obviously, we want the curvature color. So we are going to use ramp from attribute, and based on the curvature. Okay, we need points because we are working with points, and now we get this. Okay, let's try curvature. We get these nice outlines based on the edges where there are like really curved uh, places. We want to invert this for our scenario. Okay, just to get really like dark and kind of cartoony feel. And now we need to combine this with the color from our point warp. So let's use attribute warp. Attribute warp, and our input will be the first our color, and the second input we will use this color from curvature. So let's plug in the position. We don't really want to change the position, and plug in the color, but we want to to just mix the color or multiply it again. So let's multiply this our color from the second input, because these are all the attributes for the first the default attributes from the first input. But if you want to get an attribute from the second input, you need to import it. Import point attribute from our second output, and the attribute is color, because we just changed the curvature to color. So let's multiply it and try to plug it into color. And we need to change this to our warp. Okay, so this is nice. This is comicsy feely, but we don't really want these edges, these hard edges in the lava, because we want it on the stones, but the lava shouldn't have such hard edges. So let's like mask it. I'm going to hack a bit just to simplify this. I'm not going to export additional attribute from our first point warp, but I don't really use the velocity vector inside our geometry, so I'm going to use the this vector uh, as an export for our from our displacement, or what the input to our displacement is, because our displacement is basically where it is dark and where it is white, and we can just mask by this displacement where the edges shouldn't be multiplied. So I'm just going to, and I will need a fit node as well, because if I just plug this into velocity, I will show you, and then just checks the spreadsheet for the velocity. These values are not really good because they are over 1. We always want to have a normalized attributes from 0 to 1. So I'm going to use the fit node and basically remap it. Or I didn't want to use the color, so I want to use the velocity. I'm going to use I'm going to remap it. This is a float value and velocity is a vector value, because I'm just hacking it. If we exported an attribute, we just need one component, so there's a float value. So now it's fitted to 0 from. We basically didn't remap it. We just clamped the destination, so we lost some data. So we want the destination to be from 0 to 1, but we want to source, because as we saw without the fit node, the source was over 1. We just want to go from, and it was near like this. So we want, if we go source 1, 1, and we see ones, we are probably missing some of the information. So I need to go near the maximum value, so it's mapped to 1. So it's somewhere around here, as we can see. Or maybe 1.4 is okay for us, because we see a 0.599. And then if I see zeros, my minimum is okay, but I don't see any zeros. So I will try to increase the minimum. And now I see zeros, so I just decrease it to 5. And now, do I see some really small values? Maybe 9. Okay, 9.5. You can play with this, but you are probably there are some zeros here. You are probably safe anyway, because it will not impact this that much anyway. So I just hacked my my displacement value in our velocity, and now I can reuse it in the attribute VOP by mixing it before I multiply. So I'm just going to mix the curvature color with white. I will choose. Okay, so let's just plug this curvature here, and I will go. The input will be white, the second input. I don't really need to change it, but I am going to use the velocity as a bias. And now output this here. And as you can see, we got some masking, but we are masking in a different way. So we need to invert this. So to invert it, let's go back to the VOP, and in our fit, just change this the destination minimum and destination maximum. And now you can see that inside the lava, we are not getting the details from the curvature. So let's just play with this a bit more, just to get some nicer color. Maybe darker. You can play with it based on what you want to achieve, obviously. So I want it to a bit darker. You can increase the amount of lava as well. You can bake that obviously to the emission source. So I think this is quite nice. But as I said, you can play with it to hard contents, maybe even add some additional noise. I'm going to increase the subdivision even further. It will take some time. Oh, I just overdid it maybe. But as you can see now, we have a really high res model, so all the details are there. I don't think we really need 5, maybe 4 was enough. Just cooking again. So now it looks okay. So again, and you can just go to the ROP and export it, or to the preview it in mPlay or export it to disk. If you think this displacement a bit wide, just play with the right bias. Maybe move the object as well, but you can always remap the displacement range as well. So this is it from me. If you have any questions, just feel free to ask, and enjoy. Thanks.